Show that the sum of the squares of the sides of a rhombus is equal to sum of the squares of its diagonals. అర్థం కాలేదా? మళ్ళీ చెప్తా. So this is very simple. ఇలా చేసేయచ్చు. But diagonals are not equal at the same time bisects. Bisects means they divided into two equal parts and they are perpendicular to each. Once remember the properties of rhombus. What is mentioned? In any rhombus, the diagonals are bisect. But the thing is what? We have to understand the concept, what exactly mentioned in the question. Hello guys, welcome to Root Learning Academy. Today I came with a new brand important question. Show that the sum of the squares of the sides of a rhombus is equal to sum of the squares of its diagonals. అర్థం కాలేదా? మళ్ళీ చెప్తా. Sum of the squares of the sides of a rhombus equal to sum of the squares of its diagonals. Before that, we have to know the properties of rhombus. What is a rhombus first of all? It is a quadrilateral whose all sides are equal and the diagonals are not equal at the same time bisects. Bisects means they divided into two equal parts and they are perpendicular to each. That is the property. So here first given that what else I mentioned we have to write. Sum of the squares of the sides of a rhombus. I am taking a rhombus here. Quadrilateral ABCD is a rhombus. Rhombus, let just assume that quadrilateral ABCD is a rhombus. Okay, here AC and BD are diagonals. AC and BD are diagonals. So figure. So let's say this is a rhombus A, B, C and D. So this AC and BD are the diagonals. Where I have already told you that these diagonals are perpendicular to each. So let's consider this intersecting point as O. So what do we prove exactly in the question? Required to prove. What do we prove? Sum of the squares of the sides of a rhombus. What are the sides here? AB, BC, CD and AD. These are the sides. Sum of the squares of the sides. That means AB square plus BC square plus CD square plus DA square. See, sum of the squares of the sides of a rhombus is equal to sum of the squares of its diagonals. What are the diagonals here? AC and BD. So AC square plus BD square. Hope you understand this. Sum of the squares of the sides of a rhombus is equal to sum of the squares of its diagonals. This is what we have to prove. So proof. So as we can see, the entire rhombus is divided into four triangles. Triangle AOD, AOB, BOC and COD. And all those triangles are right angle triangles. And in every right angle triangle, there is a theorem which is applicable. That is what? Yes, Pythagoras theorem, what we have already learned in trigonometry topic. So here all the triangles are right angle triangles. So by Pythagoras theorem writing, by Pythagoras theorem, hypotenuse square is equal to sum of other two sides. Sum of squares of other two sides. Right? So we are just using this condition in the question. So let's see how we'll solve. First, in triangle AOB, angle O is equal to, or angle AOB is equal to 90 degrees. So by Pythagoras theorem, what we'll get here? OA square plus OB square is equal to AB square. Take it as equation number 1. Second, in triangle BOC, angle BOC is equal to 90 degrees. So, sorry, BOC here. OB square plus OC square is equal to BC square. Why we are taking this? What do we prove? AB square plus BC square plus CD square plus DA square, right? That's what we are finding here. AB square, BC square, next CD and DA we have to find. So OB square plus OC square is equal to BC square. All the triangles are very similar here. See, this is OAB. So OA square plus OB square is equal to AB square. Next here, this is the triangle OBC. So OB square plus OC square is equal to BC square. Take it as equation number 2. In triangle COD, angle COD is equal to 90 degrees. Again, by using Pythagoras theorem here, what we'll get? This is the triangle OCD. So OC square plus OD square is equal to CD square. Equation number 3. And the last one, in triangle DOA. So here this is the triangle OA and D. All the triangles I just take AOB, BOC, COD and DOA. So OA square plus OD square is equal to AD square. Equation number 4. Do we got our LHS here? AB square, BC square, CD square and DA square, right? Already we got our LHS. So our priority is to add equation 1, 2, 3 and 4. That's it. Already we got half of our answers. See, AB square plus BC square plus CD square plus DA square. LHS is completed. Now our priority to prove RHS, AC and BD. What else we have in RHS? We have to convert them into AC and BD. So first write everything. OA square plus OB square plus OB square plus OC square plus OC square plus OD square plus OD square plus OA square. Right? So now once remember the properties of rhombus. What is mentioned? In any rhombus, the diagonals are bisect or they are perpendicular. Bisect means what? They are divided into 2 equal parts. So in this rhombus, if you observe, OA is equal to OC, isn't it? Because OA is a point where 2 diagonals are bisects. So if OA is equal to OC, that is equal to AC by 2. Half of the total diagonal, half of the AC, that is OA and OC. Similarly, OB is equal to OD. See, OB is equal to OD and that is equal to BD by 2. So wherever we have OA, OC, OB, OD, we have to substitute AC by 2 and BD by 2. Why? Because we have to prove the RHS in terms of AC square and BD square. So once here, OA square plus OA square, 2 OA square, OB square plus OB square, 2 OB square, OC square plus OC square, 2 OC square and OD square plus OD square, 2 OC. Means all the terms are repeated 2 times. So we can write it as 2 of OA square plus OB square plus OC square plus OD square. Yeah. So we have to convert all the RHS in terms of AC and BD. Before that, I am writing AB square plus BC square plus CD square plus DA square is equal to 2 of, what do we got now? OA square plus OB square plus OC square plus OD square. Because all the terms are repeated 2 times, so I just have separated these 2 and writing 2 of OA square plus OB square plus OC square plus OD square. Now, as I said, OA and OC can be written as AC by 2. So instead of OA square, I am writing AC by 2 whole square plus instead of OB what? AB BD by 2 whole square plus AC by 2 whole square plus BD by 2 whole square. Now again you can see all these are repeated 2 times. So I'm writing this as 2 of AC square by 4. See, AC square by 2. AC by 2 whole square. AC square, 2 square is equal to 4. AC square by 4. Because it is repeated 2 times. AC is by 2 whole square. AC by 2 whole square. I am writing 2 of AC by 2 whole square. Plus 2 of BD square by 4. Right? Hope you understand. BD square by 2 plus BD square. BD by 2 whole square plus BD by 2 whole square. 2 BD by 2 whole square. BD by 2 whole square. So BD square, 2 square. 2 square is equal to 4. Now this 2 is separated from here. 2 of AC square by 2 plus BD square by 2. 2 2s are 4. Sorry, not 2, 4 here. 4 here. 2 2s are 4. And both the denominators are same. So the LCM is 4. And the numerator is AC square plus BD square by 4. So this 4 cancel. This is what? AC square plus BD square. And it is equal to AB square plus BC square plus CD square plus DA square. So the sum of the squares of the sides of a rhombus is equal to sum of the squares of a diagonals. Hence proved. That's it. So this is very simple. But the thing is what? We have to understand the concept of what exactly mentioned in the question. We have to prove the sum of the squares of the sides of a rhombus is equal to sum of the squares of a diagonals. So first we have to take a rhombus, consider the properties of rhombus, and already we know that the diagonals are bisect and they are perpendicular to each. So the diagonals of rhombus divides its interior into 4 right angle triangles. By using that 4 right angle triangles, we have concluded the Pythagoras theorem. So here the opposite hypotenuse square is equal to sum of the squares of remaining 2 sides. That's how we got our 4 equations. By using these 4 equations, we got our LHS. And by simplifying the RHS into the rhombus properties of rhombus, we used to get AC and BD. That's it. Very simple. Thank you so much. So this is what the question is. Hope you understand the solution. If you understand, please like, share and subscribe my channel. And I have already made few videos on similar triangles. If you are not watched that video, please go through my channel and visit the videos. Thank you.